different screens for your different color?
Got a question for you.
We haven't covered the door.
Oh. Does it make much difference once I get my shiny white head in there?
Well,
Doesn't the
for
automatic white
different-
balance?
For the different screens, there's two different.
Yes, it definitely does.
It does, eh?
It hasn't updated for mine yet.
Like as you moved it over, it got darker and then it picked up the lights so that there's no glare.
Which is important when you're bald. Yeah. Lovely, much better, don't you think? Or does it make any difference?
I still can't see you on my screen. Oh, you disappeared.
I disappeared?
You disappeared over
This
there.
is lagging.
Very badly.
Okay. Because actually I can see. Okay. Here's my question. What things about a curve can you find out about using just the original equation? What things can you find out about a curve from the equation? Short answer. Comma separated values. And, oh wait, just a second. Are you guys able to type it into Socrata?
Yeah.
Because I haven't started yet.
Refresh. Let's see what it says.
Oh, okay, just a minute. Maybe it'll work.
Waiting for your teacher to start. Alright,
Did it start?
I think so.
Yeah.
It's finally done.
So, things you can find out from the first derivative.
From the first derivative? Or
Sorry, from the original equation.
Alright,
Sorry.
final,
Sorry.
final answer.
Is that your final answer?
7.
Go in.
It feels like I did this so long ago.
Really?
Like Wednesday.
Wednesday, yeah.
I totally don't remember any of
That's okay. I've been,
what to say.
is that your answer?
It's part answer, part questioning.
Oh, can you answer again?
No.
Oh.
We can-
There's a lot of
RJ can
stuff
help
you can
me.
get from the original equation.
RJ can help.
Well, I thought you were talking about those 3 steps.
Well, if you go through the curve sketching lesson, there's like 7, they break it down into 7 steps. And it's a fairly standard algorithm for
I've
curve
completed the
sketching.
activity.
Good for you. No, you're not till we talk about it.
I'm going to say.
Don't know what to say?
Well, technically it's mine right, just for the wrong lesson.
There we go.
Oh, I have more things to say. I wonder if I log out and log back in if that.
Oh, don't worry about it, RJ.
Too late. If I log out.
I'm just going to go with that. It's not all of it, but.
So, ooh, that came in. X and Y coordinates, slope, y-intercept. Yeah.
Not slow.
Slope.
Dang
What do you
it.
mean
Not
by
that.
Oh, I guess you can tell the x and y coordinates because you just plug them in from the original equation. I see what you mean
Yeah,
now.
that's what I meant.
Yeah, okay. All right.
What else?
So, well, we've got, somebody said pi, delicious pi. That must be relogged in RJ. Is that right? Judging by the smirkiness of the participants, I would say that's probably right.
I didn't know we did it.
Good.
Well, you
So,
said don't worry about it.
hey, what's the y-intercept of this? Y equals x squared minus 2x plus 1. What's the y-intercept?
1.
Yes!
So you
Fine.
can, yeah, you can find the 1.
Yeah, you can find the y-intercept. If it's really complicated, you substitute a 0 for x, but with polynomials, it's pretty straightforward. You look at that number right there. Yeah, it's 1. Okay, how would I find the x-intercepts? I mean, besides graphing it.
Factor in.
Oh, factor it. What a good idea. Yeah. What does this factor to? Made it easy.
X minus 1 and x minus 1.
Yeah, x minus 1 squared. Good. So there are the factors. All right. And so what are the x-intercepts?
1 and 0.
1
And
is
1 and that's it.
Okay.
Yeah, that's right. So we get x-intercepts when x minus 1 is equal to 0. And so in this case, x is equal to 1.
When is it?
So
When
that's
you
like the min.
factor something, and is it when there's a, like a number out front? Is that when there's a zero intercept? You intercept at zero?
If you have, so you're thinking about something that looks like this, if we had factored it. Oh, here, let me modify it a bit. If it looked like that,
Yeah.
yes. Now, it's going to be 0 when x minus 1 is 0, and it's also going to be 0 when x is 0.
That's
When
okay.
either of those two factors is 0. And so you solve for x, and solving for x there is real easy.
Yes.
And what if it was 2x?
2x is 0, so it's equal to 0.
Yeah, so once again, that would be an x
Okay.
equals 0. Yeah, okay? So you can find your x-intercepts. What's special about this parabola?
The minimal is on the x-axis.
Yeah, the minimum is on the x-axis. It comes down and kisses the x-axis. That's exactly right. And how do you find out what intervals are positive and what intervals are negative? Something special about this one again.
Try it again.
Really? Factor it again? Did you just say that? You could make an
The
interval
fact that-
table,
Yeah, that's the word I was looking for.
but
So
it
that's
would
two.
change, yeah, it's even easier than that. It would change sign at x equals 1. But RJ, you've already said, like, it comes down and it's got a minimum that touches the x-axis. Okay.
So we can just tell if it's still right, it's increasing, or just to the left it's decreasing.
So basically, looking at this, any number squared is always
Positive.
positive. This graph is always going to be
How was the deal?
positive, yeah. So if you did an interval table and did the plus minus thing on this, it would be plus plus all the time. Right, okay.
Wait,
Got-
wouldn't it be plus plus plus?
There's really only one place where it touches the x-axis. So you're right. If this,
So you ignore the zero in that case,
well, no, you'd say when x is between negative infinity and
zero.
1.
And 1. 0 is not factor.
Yeah, I erased the 0 factor.
Alright,
Yeah. Right, but when x goes from negative infinity to plus 1, the thing is positive, and when from plus 1 on, the thing is positive. Okay. Oh, Megan, gee, don't eat your hair.
I'm tired. I don't want people to see me yawning.
How
Even
does
if it's just you two.
Okay, finish is way up here. Okay, I finished that. Get reports.
Yeah, we're still waiting for you.
We're still waiting for me. View dashboard. Select an option below to end the activity. Okay, got a quick question. It's a short answer. And I have started it, but my quick question is this. What information can you get from the second derivative? No cheating. No Googling. What information can you get from the second derivative? And has it started?
Yeah.
Okay. I have one answer. Is that RJ's?
Yeah. It's
I don't know what else to say.
Oh, I don't have an answer from you yet.
Yeah, I know.
Okay,
I'm
all right.
finishing it up. We're just gonna say that because he's probably got the other stuff.
Let's try now. Well, I guess, yeah, actually, yeah. The derivative.
I
Right?
said second derivative.
Did I say second derivative?
Yes.
I don't think you did.
No, you said second derivative.
Oh, wait a minute. Well, we'll look at this in just a little while because it's going on YouTube. We're going to see who's right.
I thought you
Yes.
said first.
I'm pretty sure I just said the derivative, but we'll
I'm pretty
see.
sure you
RJ's always being persecuted by technology, so we'll see.
You'll like it.
What is the derivative of this one?
2x.
2x minus 2. Hooray. Yeah. So, yeah, the derivative tells you the slope, right? Which is what Megan said. Somebody said, and I won't say who it
I
was.
wonder of the two of
It's
us.
concave
said
up or
slope?
concave down. Fortunately, they are saving themselves by saying, oh, you said the second derivative.
Play the video back, I dare you.
Yeah, well, we'll do that. Okay, all right. It will tell you if it's increasing or decreasing. Yes.
Yes.
Okay, now, how do you decide? What do you do to tell you where it's increasing and decreasing? What do you do with this?
Interval table.
You make an interval table. It's
Oh
so
my
exciting. Yeah.
gosh.
Now, there's one thing that you guys did not say,
Yeah.
and what is that?
Critical points.
Critical points. Critical points. Correct. Yeah. And how do you find the critical points? In this case, just a max or a min.
Set y equals 0.
That's right. You want to find where the slope is 0, or you want to find out where the derivative does not exist. Okay. So you set the slope equals 0, and when you solve for x, it's just 1. So we have a critical point of 1. And if we were ignorant about this curve, we wouldn't know if that's a maximum or a minimum yet. Okay. And we could set up our interval table here. And what are the intervals?
Where x negative infinity to 1, and then 1 to infinity.
Ignore me.
Okay, we're just ignoring Megan for now.
I'm so tired.
Yep. And
I
we
feel like-
really only have one factor. Okay, in here it's yeah, and in here it's yeah, and so the function is increasing or decreasing? Decreasing, yeah. And in here it's correct. Very good.
After lunch,
So
my
we
brain
can-
just stops.
What's that? Your brain shuts down after lunch? Builds up with
I'm
metabolic
tired,
products?
It's time for a nap.
I think I left mine in Myers.
Friday? Okay. Did you go all the way to Warden today?
Yeah.
Warrior? Okay.
I did it many
Good for
times.
you.
I had to do it many times
Trana.
to see if I pass it.
Okay.
Trying.
Very good. We have no, like, this thing's continuous. We got, like, no weirdness going on. The derivative exists everywhere. Okay. Good. Hey,
Oh my God.
question. Got a question for you.
Is this one the second derivative?
Yeah. Yeah, according to RJ, it's the same as last time,
Watch the video.
which it's not.
I think you said second this time because the first time you said the derivative and the first derivative at the same time.
No, derivative and first derivative are the same thing.
Or the original, and then he said,
RJ, get it right.
Okay. Yeah, actually, we don't. Ooh,
Ooh.
sorry. Sorry, quiz. I want a quick question instead. I almost started you guys on a quiz. Okay, got a question for you, and it goes like this.
Headache.
Got a headache. It's going to be a short answer question, and I'm going to start it right now. Do I want to start a new one anyway? Okay, I didn't finish that. I didn't.
Excuse me,
Okay,
RJ. Don't look at my answers.
is RJ looking
Oh,
at your answers
What? Where
already?
did they go?
because the test hadn't started yet. That's what I was wondering what you were typing.
It started on mine.
All that wasted effort. That's my fault. So
So what's the question?
question is this. What information about a curve can you get from the second derivative? Dun, dun, dun.
Get on with the call. If something I'm trying to remember what it's called, they can't, so we're just gonna go with that.
What about the little penguin?
Yeah.
Where was he staying? Oh, yeah. Concave up or concave down?
There's something else I can't remember what it was. So.
Oh,
The where it, the point of
Inflection.
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 That's the other thing. I can't remember what it's called.
Yeah, that's right. Does this curve have a point of inflection?
Yes.
No!
That's why I never answer. I don't know what's happening.
No. No, actually, it doesn't. Y double prime is.
Two.
Yeah, that's right. Okay. And
Wah!
yeah, so how do you find points of inflection actually?
Where the turning point, the cut, the points are.
Halfway between the
Halfway between critical points is also wrong. It's often between critical points, but not necessarily between critical points, and definitely hardly ever halfway in between, believe it or not.
Well, in the one video I showed it halfway between, so.
Yeah, approximately halfway in between. Okay. Hey, do you know how you find the point of inflection?
Where it switches from concave up.
Yeah, and so what's going to be true about the value of the second derivative where it switches from concave up to concave down?
0.
Yeah, the second derivative would be equal to 0. So 0 equals 2. No, we do not have a point of inflection with this one.
Good.
It's concave up everywhere. We had a point of inflection. How do we determine where it's concave up and concave down?
With an interval table.
We'd use an interval table.
Oh my god.
What a good plan. Yes. Okay, now, how do we know this is concave up everywhere? How do we know that this actually comes to a minimum? It's positive. Yeah, it's positive at the critical point. It's positive everywhere. But at that critical point, you can do what's called the second derivative test and see that it comes to a minimum there.
It technically could be positive and still be maximum if you limit the domain. Like
If you limit the domain, yeah.
But we're not limiting the domain.
I don't understand. Don't assume because it's always positive that.
Correct. Okay. There are graphical features that we did not, that we wouldn't pick up. So I'm gonna, hey, got a question for you. Okay, I'm gonna finish this. Gonna finish it. To dashboard. Oh, let's go to the oh, that's the better way to do it. Okay, got a quick question for you. And this one is going to be a short answer. And here's my question. All right, there's something else that you could find. It's a graphical feature. And you can get it from the equation itself. But we haven't talked about it. And by the way, this function does not have these
Yes.
graphical features. I want you to phrase your answer like a question. What graphical features?
Are we on Jeopardy now?
What's that? Yeah,
What
it's kind of
is?
like Jeopardy. What is? What are? So some graphical features. This kind of polynomials do not have them. But
Entering it as a what are.
You know,
Yeah,
I'll
but-
go back and they'll let you put in your answer.
oh, okay. I'm waiting for the last ones.
I'm thinking.
Ah. Do 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 do.
Oh, come on. So when I
do,
did this, I can yell.
do 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 dun 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 no no boom. And what are things? Yes. And my first answer, what are asymptotes? Yeah. So,
I was not.
okay, now that kind of, I don't know what kind of dancing that is.
It's the
was
asymptote
not-
dance.
Oh, the asymptote dance, yeah. That'll make sense. So what are asymptotes, right? What kind of functions typically have asymptotes?
Rational,
Rational functions typically have asymptotes.
not rational.
So how do we find vertical asymptotes?
Where
Where?
X
Where the
numerator is
Zero.
the
Denominator is 0.
Yeah.
where the denominator goes to 0.
Yeah.
So yeah, you might factor the denominator, see where it goes to 0. Pardon me?
I just realized the number fighter.
Yeah, well, we're doing optimization on Monday, so we'll invite Eric on Monday.
Alright.
He'll like it. It'll be good. I made the grade 9s make us boxes for optimization. It'll be fun.
Oh, that's what those are for.
They're for the grade 9s, but they're also for calculus, so
That's weird.
it'd be good. Yeah.
We're taking your boxes.
It's all right, right?
And give me an example. Okay. Got a question for you. Finish. To dashboard. To the dashboard. Short answer question. Oh, and I'm going to start it right now. Single and anonymous. Give me an equation that has a horizontal asymptote of y equals 2. An equation that has a horizontal asymptote, a rational equation, well, an equation that has a horizontal asymptote of x equals 2. Oh, you can be good at these. It's really pretty simple. No. It's simple. These are easy. Oh no. We're all started. It's all good. You know what? Maybe if I didn't hit finish, I think I can just ask another question. I'm going to do that. Okay. Got an answer? From? All right.
That should work.
No, I'm not. You've got to give an answer. People are getting bored. It's all over the internet right now. Bored. We're just waiting. Y equals 2. Big puffy cheeks.
It's not
It's not a substitute. 2. Okay, so here, I'm going to screen share. One of these is right, and one of them's wrong.
Don't.
Get a screen
that's
share.
totally
One of
wrong.
these is-
I know mine's wrong.
One of these is right, and one of these is wrong, and oh, there we go. That's the great thing about the internet. You can be embarrassed in front of everybody, but really nobody's paying any attention. Okay, one of them's right, one of them's wrong. I'm going to start a vote. You guys can vote. Which one is,
Definitely wrong.
which one's right? Everybody votes. Who else voted? And it looks like 100% have voted for the one that's wrong.
Seriously?
Yeah. Actually, you know what? I guess yours is kind of wrong too, but it's less wrong than.
I thought
Well,
So
I
Kyle
thought
is
mine was
offline.
really-
What's that?
Chicago is offline.
Oh, mine's not.
mine's not.
Okay, so we had one that looked like this. Both of these are instructive to look at, so that's good.
I thought you wanted horizontal.
Horizontal,
Oh,
yeah.
Horizontal. Oh,
So yours is actually an oblique asymptote. So yours is x squared.
Mine is a vertical asymptote. Isn't it?
Yeah, so you've got a vertical asymptote. You also have what's known as an oblique asymptote,
Ah, I always get those backwards.
which technically we're not supposed to teach you guys because it'll destroy your brains.
Zach! My brain is melting!
No,
An oblique asymptote. Okay, there we go.
mine
So
has-
you do have a vertical asymptote of that. Yeah.
That's what I thought. I thought you wanted a vertical because that's what you just talked
He
about.
said horizontal.
I know, but right before you talked about horizontal or vertical.
It doesn't make it right, RJ.
He still said horizontal.
There we go. If you had just changed yours to that, that would
Yeah.
have a horizontal asymptote. The equation you actually gave, g of x
It's just
equals,
Straight line.
it's a straight line, yeah.
Yeah.
If you do it in Socrative and look at it, but yeah, it's a straight
Yeah, I
line.
know. I just put it in because I was like, I don't know what I'm trying to
Yeah.
put in.
There we go.
I
Okay.
knew it equaled 0 at some point, so.
Yeah, so
Or equal to
we
it
had
somewhere.
repeated factors in the top and bottom, and they would cancel out. You would just get a straight line. If we kind of jiggly it around a little bit, then we're going to get that that asymptote, that horizontal asymptote. Okay? And RJ's, yours will actually have
Vertical asymptote.
what's known as an oblique asymptote. It will have a vertical asymptote when x is equal to 2, and then it will have an oblique asymptote of
I always get those backwards on the line.
of y equals x. Okay, let's take a look at it for a second. So, Desmos.com, and launch the calculator. And
I can't do
y equals 2x divided by x.
My phone.
There's Meg's.
Alright, so nothing's happening on my phone.
it. Nailed it.
Unfortunately, we would have
Technically,
we'd have a debate with Jacob Dickinson over yeah, like it. That's not bad, right?
technically, it's still like,
It touches the line though.
it
So.
touches the line,
Yeah.
but like technically,
So there, if we tweak it a little bit, we got our vertical asymptote. Okay. Let's take a look at RJ's for a second.
Picture of me.
Y equals x squared minus 2x plus 5, and then we're going to make that over. We make everything over. Divided by x minus 2.
Oh, it's one of those ones.
It's one of the, yeah. Oh no, it's not that bad. Not that bad.
Oh, I have one of those. Oh.
Okay.
I'm joining my video chat. if you don't mind.
Yeah, my Microsoft
Hop
Windows is
on.
not responding
Hop
anymore.
on over.
Oh, is that right? Okay.
I think my computer's dead.
All right. So RJ did manufacture an asymptote that has 2 in the equation.
There's
2 somewhere in
there
there.
somewhere.
Anywhere. Okay. Also, you'll notice that if we multiply the top and bottom of this,
Yeah.
I'm in the other room.
We have a join guest.
Really? Hey, Luke. Hey, Luke.
He's muted.
Oh, he's muted. Okay. Luke's been muted. There we go.
Alright, so my.
Sorry I was late, I didn't know if you were doing this today or not, so.
Yeah, sorry about that. I didn't actually say we were going to have a video conference, so once again, it's all my fault. I think we're probably okay. We've just been sort of reviewing the curve sketching. We've just done a bunch of curve sketching stuff and tried some Socrative, so I think you're probably pretty good on that. I looked at your assignment. Your assignment looks good.
Alright,
And we're going to have a test on Wednesday if we decided that works for you.
yeah, that works.
Okay. Now I'll just post what it's going to cover. It's going to be like product rule, quotient rule, like the rules, and I want you to be able to reproduce, do the proof of like the product rule or something like that.
Okay.
All right. Good. And oh yeah, you can't see me anyway. I'm screen sharing right now.
Yeah.
Oh yeah.
You'd be impressed though. I looked right into your one eye here
That's what he
locally.
did.
So anyways, we were just going over those, I guess, like the CEMC, they break it down into, I think, about 7 or 8 steps for the algorithm for curve sketching. And we've covered, like, what the equation tells you, what the first derivative tells you, what the second derivative tells you. And then we've just generated some functions here that have some asymptotes. And so can you see this one on top?
Yeah.
Yeah. Hey, what kind of an asymptote does that have?
I don't know.
It's a really gross
X
one.
can't equal 0, so horizontal was it? Or vertical there?
Oh, let's see here now. Oh, for the top one?
Yeah.
Actually, you know what? In this case, x can't equal 0, but there are sort of factors that cancel top and bottom. So if you look at it, we can actually rewrite that. So we can multiply this top and bottom by 1 over x.
Oh, okay.
Okay, and then it turns into like 2 plus 1 over x over 1. So that's sort of an equivalent form And as x gets really big, either positive or negative, this becomes 2 plus 1 over infinity, or 2 plus 1 over a really big number. Basically, it just turns into 2 over 1 again.
Oh, did you piece out?
Now I'm here finally.
RJ involuntarily pieced out.
Alright, wait, so I'm not on the call anymore? Good.
All right. Does that make sense, Luke?
Yeah,
Okay.
I think you know what you're saying.
Yeah. So that's a horizontal asymptote, and this is sort of how you fish them out. You'll see those on the CEMC website. RJ actually generated an even more interesting one. So RJ generated one that has an oblique asymptote, and the oblique asymptote is the equation of y equals x. So this green line is, ooh, there we go. This green line is actually an oblique asymptote.
Okay.
All right, and the good news is oblique asymptotes, you don't actually have to know how to do them. Because it's Ontario curriculum. I don't know.
Okay.
For science.
I think I did that in like the math course, but
Beg your pardon?
I think you do that in like the math course, like advanced functions.
Yeah, sometimes people talk about, exactly, yeah. Sometimes people talk about it in advanced functions. Okay, you're getting the stink eye from Megan, though, she's not sure.
I think,
Pardon me?
yeah, I
Okay.
think you did at least once.
Did I do oblique asymptotes?
Probably.
Good. Okay. So Luke, are you able to join us on Monday?
Well, yeah, I'll be here for
Okay.
like 2 o'clock or.
Yeah, let's go. We'll try a little bit earlier, and we're going to start optimization on Monday. Curve sketching is sort of a big ugly unit. So, do you have any questions about curve sketching?
Us?
Throw it out to the audience. You mean no, not yet?
Yeah.
Okay. All right. Good. Okay. So we'll see you on Monday.
Yeah. So our test is just in the 3 rules then, and proving a product rule or something.
Yeah. So I'll post that. It'll be the 3 rules: product rule and equations of tangents. But I can see everybody's actually pretty good at that now. So
Alright.
I think it'll be easy.
Alright.
Okay. Good. Thanks.
See you guys
Luke.
on Monday.
See you on Monday, Luke.
Yeah.
But yeah, my computer like froze.
Yeah.
That's
It
why
was-
like.
Oh, I should show you how our faces were frozen. It was really nice.
I'm like this.
Wait, no, we can recreate it. I'm like